Okay, our speaker tonight is Brian Higgins, and he's going to be talking about, I've forgotten the name of it. It's just basically
Seeing Eye Guide Robot.
Seeing Eye Guide Robot. Okay.
All right. Maybe I'll try to put my hand down there. How's that? Okay. When Rose called me up and asked if I could speak, I gave her a couple different titles. I said, first, you could call this How Not to Start a Robot Company. The second one was, can a blind man come up with a solution for autonomous robot? And then I said, a robot guide for the blind, and that's what she picked. So we'll try to stick with her choice. Basically, I've started a development work group, and it's developing a robot guide for the blind, sort of tailoring after a seeing eye guide dog. And I'm a blind veteran myself, a blind rehab specialist. I work at the VA Palo Alto Hospital in blind rehab, and this is kind of what's pulled me to where I am right now, developing this robot guide. I've been following the trends of technology. I joined the robotics club 5-6 years ago, and so here I am today. The software and hardware team that we put together is a sprinkle of different members. We've got some HBRC members, some representatives from Carnegie Mellon University, Silicon Valley. We're prompted to make sure we get the name right. And then there's a few members from the HBRHomeBrew Robotics that makes up the ClearPath navigation software development team. So what's the problem in developing anything? You always start out with the problem. And so the issue here is trying to provide the blind with intelligent navigation. And what have they had for 100 years or so? The white cane, similar to my fancy one here. And then the guide dog right after World War II, they came out with a seeing eye guide dog. And that does increase people's mobility. It does, I think it's part placebo, but 50-50 partnership, whether it's a placebo or not. It does speed up their mobility. They can get around faster because they do have more confidence. And then gizmos is really what got me here, and I have a variety of them here. There's been a variety of high-tech devices that's been being made for blind rehab, for development for people who are blind. And amazingly enough, one of the first ones, they're primarily ping sensors, but the first one is the MOWAT sensor, which actually dates back to the 70s. Probably the late 70s, so I was quite surprised at that. And actually, my overall goal here is I have a progressive eye disease that I've lost about 98% of my vision right now, and probably got 2 more years before I'm totally blind. So by the time I'm totally blind, I want to be able to get rid of this, throw it away, and then have my robot guide me around. So that's my major goal here. And but what's taken me is the technology that I've been exploring, and this is the MOWAT sensor. Primarily has 2 settings, and it's an ultrasonic sensor that will pick up and vibrate when it comes in contact with something. So another way to develop ClearPath navigation. And actually, if you get used to this and acclimate to it, you can actually tell how thick a tree is in front of you, or a signpost. And this is how, I had a photography studio for 25 years. And so, you know, I couldn't, when I started losing my vision and couldn't navigate through stores, I didn't really want to get the white cane. Not too many brides would have confidence in a photographer that had a white cane in one hand and a camera in the other. Just didn't instill the confidence that we need. So I, you know, kind of discreetly held this down on my side and could just navigate through stores. So there's gizmos. The other one, this is high tech, and this is something that I've been following. This is it's called the Trekker, but it's a GPS for the blind. It has tactile sleeve over an old PDA. This is kind of outdated now. The newer one looks more like a TV remote without all these tactile buttons and so forth. So the blindness community has been trying to drag themselves into the 21st century. And I'm here to push them even further. Well, this has some controversy. How many blind people are there in the world and in the U.S.? Dave here has prompted me to research. I came up with some figures originally, and actually I spent a couple hours this afternoon keep researching, and I found all kinds of figures. So I kind of took an average here. So there's 11.4 million blind or visually impaired people in the U.S., probably 120 million worldwide. Quite a few people in Africa that have river blindness. So what do people want? And so the software development group, we've been meeting since May. We meet on a Yahoo group, and we've been trying to determine what do you need? How do you solve this problem? And so you basically need a lot more detail about the environment. And a white cane's not enough. You actually swing it on an arc, a little wider than your body, and you interrogate the environment by navigating that way. So if you can imagine, everyone can close their eyes and try to imagine dragging a stick in front of you and trying to get through an environment like this room here with all the chairs. The guide dog's not enough. It's intelligent, but I think my investigation of the guide dog finds it's not as intelligent as people. I think people have this general concept, it's the super wonder dog and it can do anything and take you anywhere. But if it sees another dog or a cat, it can tend, with a wrong training, it'll take off chasing the cat. And with a guide robot, you don't have to clean up after it either. And so the gizmos, again, that's not enough either. But we're including this on the robot, some of the gizmos that I've come to know and love here. So there's a couple phases, and the platform that we're using right now is just a partial solution. We're using this indoors, but I think it will work outdoors as well. Price point, like I said, how not to run a robot business. I have an SBA, Small Business Administration counselor, and we go talking all these figures. He wants me to get $3,000 for this, but it has a potential. Guide dogs, there are 12 guide dog foundations in the country, and out of the 10,000 people that have guide dogs, not one person pays for a guide dog, which can run anywhere from $30,000 to $70,000 total cost to get it to the person who's blind. So the solution is to find a platform that really is a sensor-rich platform that will interrogate a clear path through the environment, which we call our world today. It's going to take multiple sensors. It will provide you with details of the environment. And I think clear path detection is the important thing. Over the past year, I've been studying human navigation and how we accomplish that. Actually, vision is a subconscious sense that we have that really makes navigation for the sighted simple. You don't even know you're doing it. And so, again, this robot will avoid objects. That's very important. And it can provide navigation with GPS, compass. So the whole theory behind this is that the robot guide will be a companion. And again, I think phase 1 or 2, it's going to be that same thing that a guide dog would be. It would be a partner, a 50-50 partner. I think the blind person has to know orientation, know where they are, provide some of those things. But I think a sensor-rich platform can really be a fantastic tool to guide you around environments and get you from point A to point B. As I've studied human navigation, I've slowly working on how we navigate. And I've come up with pretty much what I call the 10-degree of surface navigation protocol. And primarily, there's 4 basic components right now as I've developed it. And so step 1 is like orientate. Step 2 is scan. Plan is the second step, and then store. So orientate, scan, plan, and store. And hopefully this is what our robot will be able to do. And that's my travel protocol that I've developed. And then the group has been deciding what hardware is needed, and then software support. And like I mentioned earlier, it is really a subconscious skill. If everyone here closes your eyes, and now once you do that, try to figure out how to get to your car from here. And how many think they could do that with their eyes closed to get to your car? Yes. Yes. Some people have problems finding your eyes open.
Or you just follow the sound.
Okay, so this is 1 degree or 10 degrees. I'm still working on how many degrees we need. But I think directly in front of you is the primary focus that a robot should focus on. Because no matter where I turn, I mean, that's my primary interest. With only 4% of my vision left, I bike to work every day. How do I do it? I follow the white line on the bike path. I use it as a tractor beam. So, and primarily, I mean, there will be times where maybe there's something coming in from 90 degrees or side streets, but at some point they'll be in front of you. And so I think that's the primary focus. And if you're having some sort of sensor that will sniff 360, get that data, your primary focus is right in front. So this is my part of my protocol. Travel, everything's a trip. Well, I wouldn't say that back in the 60s or 70s. And I'm from that era, but no. So, when you get up in the morning, if you get up out of bed, that's trip 1. I mean, you could count them, probably 100 trips if you really plot it out for a robot. So you get up in the morning, I don't know where you go first, I don't really want to know, but getting up out of bed and playing your first route, that's trip 1. Not that you'd have a robot do all of that, but you boil human navigation down, and this is what Ed and Dave has been working on me for the last however many months. How are we going to do this? How are you going to create an engineering equation that we can get hardware and software to do what you need it to? Of course, like I said, step 1 of the protocol is orientation, knowing your location. Scanning the surface is very important, and of course, obstacle avoidance. So trip, travel, and navigate. I think we probably, and we've added the store, because I think as we go through smart buildings, the world's becoming smarter, and you'll be able to store that information. Ed says that you'll be in the future, you'll be able to go into a building and your robot will actually pick up the layout and tell you where things are. Remember, this is what the blind do, is recalling using mental maps. That's how we, so if I've been here before, I know that pretty much if I go to my right, go out the door and take a right, and then take a left, and then I'll go straight for probably 100 feet, I'll find the front door, and then my wife is parked out to the right, another 100, 150 feet. So mental maps is a key to getting around if you're blind or visually impaired. And you can actually lay out your whole environment with maps. Of course, you have to monitor travel. One of the neat things about becoming blind is that your visual cortex, it stopped being used by your vision. And it's a pretty good size of your brain and back. It starts to take up other functions. And One of the functions I'm using for my visual cortex to retrain it is taste wine, but we won't go there. But the other function I'm using for my visual cortex is, to hear. And you can actually hear the walls. You can actually hear when there's a doorway that's open as you're walking by, because there's sort of an absence of sound, or reflection of sound. So it's, becoming blind is cool. Do you believe that? Okay. So, and again, I think, and as one who's traveled in what I call our smart world, there are lines everywhere. And being a photographer, I threw in some photos here that try to illustrate my point. This is Half Moon Bay, but you'll find lines that you can follow anywhere. And one of the techniques that we use is when we find a hallway and we know it's 100 feet, there's usually a wall to follow. So it's called shoreline. So you can follow that. And so I actually used a lot of the lines around, and I think painted streets, bicycle lanes, sidewalks where the sidewalk meets the grass. There are a lot of elements in our smart society that we can follow with a robot. And here's some more example of surface lines in the smart world. There's that bike path that I use every day, and the third photo from the left. As I've said before, it's a partnership. Again, the human needs to know their orientation and mobility skills. Those are key. They need a sense of direction, that auditory memory, proprioception. These are just some of the senses. Oh, here's a quiz. Here's a question for everyone. How many senses does a human have? 5, 6. Yes?
Infinite.
Infinite? I like how this guy thinks. Actually, it's up to you. I Googled that, and if you want homework, you can go home and Google that tonight, and you'll find anywhere from 9 to 27 senses. So, but that's your homework for tonight. We won't go any further than that. Okay, time distance awareness, problem solving. Okay. So what we hope, and we're doing a variety of phases, and phase 1, I think, will pretty much just get a robot that's able to pull a person who's blind, vision impaired along in whatever compass direction that person decides, and then avoid objects. And so the user will be in control of the robot in phase 1. What do you need for senses? And I think that's one of the other things that we've talked about infinitely in our user group here that meets every Tuesday night. So how many senses do you need? And I think we're up around 7 or something that will cover all the different parts of the environment that are needed to sense and interrogate the environment and guide someone along. No one sensor can do it. You need multiple sensors. You need all that data for the blind. And the main sensors are critical, scanning, again, the surface. I keep hammering away on that, and I'm not sure if I'm the only one that gets that yet, but I keep pushing the issue that scanning that surface is very important. To me, that's the focal point. I mentioned my scan and plan protocol. If I can have, if my shoulders are 3 feet wide, then I think if I have the ability to really scan that area in detail and get as much information as I can, that's the important thing. And make sure I don't fall through any open manhole covers that a public work person has left off. That has actually happened to some of the blind people I know. Okay, so we're up to the Neo, XPLemon, which everyone knows and loves. Right, Cam? And the reason we chose this is because it does have all these multiple sensors that we've been talking about. You know, the world famous LiDAR sensor, the accelerometer, Bluetooth internal, let's see, bump sensor, which actually I've used this. I've got, I bought my first XPLemon to work on, and then my wife stole it. Everyone's had that happen, I bet. But, and I've noticed that it rarely uses the bump sensor, I think, because the LDSs do such a great job. And a proximity sensor, and I don't really, I'm talking to the choir here, I don't really need to explain all the different sensors it has, but this is the platform that we've decided to work with. And we're working on, you know, like everyone else, trying to hack into the software here. Right, Dave? And again, I think this is the great thing, and I've noticed with devices that are created commercially, and no one wants to develop these things for just a few, you know, thousand people or a couple million people. They want to get mass things like the iPhone. You know, if everyone in the country will buy one, then they're really put dollars in it. And that's one of the reasons that I decided to try to do this myself, is because if someone from the blindness community doesn't do it, no one else is going to. And but this is how we get things like the LD radar or the Xbox Connect, because it's going to be in every Xbox and every kid's TV at home. They'll put the research dollars in and develop that. And so we know that the DARPA challenge, the LDS radar is used in the DARPA challenge. Have everyone seen the course that's available? Sebastian's run actually has on Udacity now. You can actually take a course in developing an autonomous car. So that's pretty cool. I think a couple in our group have signed up and will be turning their car into a robotic car. Ed's working on that right now. So this is, and I actually spoke with Sebastian Thrun at blindness convention a few years back. So the drop-offs, this kind of list, I go through some of the sensors that we think is important. The drop-off sensor is very important. The stairs or curb, or when you get to the top of a set of stairs. Actually, the whole device itself, if you look at it, it really makes a tactile sensor itself. Because if this is just pulling you along and you're holding onto it like a guide dog, then the wheels itself, if nothing else is running, becomes a tactile sensor. So if it comes to that open manhole, it'll start to tip down in it, and you'll know that there's something you don't want to proceed. But a drop-off sensor is very important, and the bump sensor. I've added ultrasonic sensors because I've been using them for so long, which is the mini guide. And then this is the 1976 MOAD sensor. This is the latest version, and I've been working with this gentleman in Australia. And it's quite interesting. When I started working with this guy, he had this go out to 8 feet, and he said, it's not safe to make it go any further. And I said, you've got to change this. So after talking to him, he's now doubled this, and I think this will go out to like 20 feet. So what this does is send out a ping, and when it comes in contact with something, this one has a speaker on it. They vibrate, and I have one on the top of the cane here too. But this is actually, the blind center that I work at actually has a program where we teach blind veterans how to use these. Because we always say, you use it along with your guide dog or cane. But I'm a proponent of using that by itself. But I'm kind of one of those wild and crazy guys that are out there. Okay, accelerometer, Bluetooth. You know, I think in phases down the road, we'll be able to, with your smartphone, talk to this robot. Proximity sensor, so you can shoreline walls when you're inside a building. RFID tag. I've been going at, one of the things that I've been doing is going out and speaking to different groups, and I've actually found an organization in Palo Alto that is developing a robust RFID tag. And they're going to be able to use this. They're called Tag Array, and they actually want to create a robust RFID tag that will act like a tractor beam and a traffic signal. Because that's one of the most dangerous things for a person who's blind. If you're trying to cross El Camino in downtown Palo Alto, you know, it's a lot of traffic, 6 lanes. And so this is one of the companies that I've met into, and I think that's the beauty behind developing a robot. I mean, a guide dog, he's not going to grow any more sensors, but with a robot, you know, the next version, the next phase will have, you know, the tag array. It will next have the latest smartphone connection. Or somebody sent, what did someone, oh, someone sent me an email today of a skateboard that has a sensor that will pick up your brain waves, and you can look at something and the skateboard will head that direction. I think I sent it out to the software group. So compass is important along with GPS. Everyone's using GPS, and the GPS, of course, is another one of those things that is in the blind community. SLAM, that's pretty much how XPLemon uses the LiDAR radar, and I really won't go into that here. So this is a development, and we've tried to narrow down. I think this is the big challenge: is you get a concept, and what do you do? And one of the things I've noticed in the robotics club is that, you know, there's a lot of new sensors out, and we try to work around using the sensor. But if you take the concept and really try to work on how do you develop this, so I pushed the group to come up with at least 3 different concepts and what way to go, what way to develop the software, and we're making Ed learn Python and ROS. But so the first concept, the first path that we were going to take was find a wall. So one of us is working with the concept of how can we hack into the XPLemon, and how can we decide to find a wall. And the reason I think surface navigation is important, because due to gravity, 99.9% of everything is hooked to the surface. You know, whether it's a wall or a chair or a desk, everything's on the surface. So if you spend all your time focusing on the surface, you'll catch all the obstacles you need. Another group wanted to you know, produce and follow breadcrumbs. So that's sort of a memory storing type of thing. And then path 3 was kind of the concept that I want to go in, is just create something that's robot that will just pull you along, whatever direction you point it in, have it search out those obstacles and try to analyze what that, perhaps that obstacle is. Is it a wall? Is it a chair leg? Is it someone's foot or backpack? To determine the mass and then try to navigate around it. Okay, so this is some contact information. The company I started is IntelliSite. Here's my email address, my website, and the development work group for anyone that's interested. Like I said, we meet every Tuesday night at 8:30 for an hour. We actually adapted something from the Robotics Club. At the end of the thing, we have random access. And sometimes we can get the 2 Daves going here. And I'm asleep by the time they're done. But, so, that's the robot guide for the blind.
Questions? Cam?
So, Brian, you're talking about clear path and this surface, analyzing the surface. The XPLemon is 4 inches high. Do you think that's low enough?
Yeah, because, you know, if you get back to my concept, and that's my role from the blind rehab specialist, is to analyze human navigation. I've been reading everything I can. Like I said, everything's attached to the surface, and probably a lot of things, if you look around right now at all the things attached to this surface we're on, everything's taller than 4 inches. I mean, there'll be a few things that may not be. I don't know too many.
Somebody's foot.
Yeah, but their legs attached to their foot, unless they've lost their foot.
Do the dogs hear the ultrasonic? Is the frequency?
It doesn't affect the dog because actually the developer actually, well, I'm working with him. I've developed this harness here, and I'm trying to talk him in now to put this on a guide dog harness like I have it attached here. And this can be pointed, but it doesn't affect the dog. Whatever range the ultrasonic sensor is at, it doesn't affect, because he actually in Australia works with a guide dog foundation and he promotes this device for that. It's one of its primary functions. So it must not.
Question in the back.
Are you looking for developers? And coupled with that, is there anything you can share about your business plan and the type of developer relationships you have?
Okay. Well, like I said, my business plan is how not to start a business. That's how. I've been working with an SBA counselor. He's put together. He likes all these facts and figures, and he's got all kinds of projections. We are looking for anyone that's interested. Like I said, I don't think there's any company that's really going to maybe put this together. That's why I've taken on this challenge. I'm a business person. I'm a blind rehab specialist. Had a business for 25 years that was successful. So I'm doing this because it needs to be done for the blindness community. And we're looking for anyone that's interested in helping, whatever way. So far, this is open source. I think Nito has been a great supporter. We should give Nito a hand here. I think they've helped us and continue to help us get further along than we would have without their help, and provide a few units for us to work on. Did that answer your question? We are looking for all the help we can to make this happen, because I think that's my main goal. I'm not going to be able to retire. I'm always going to have to work, so I'm hoping at some point down the road that this will be enough so that I can make some money and have at least one meal a day or something.
More questions? Yes.
When you were looking at the project, how did you decide between sort of the robots doing the processing or just being more the raw information to the person to let them do the mapping in their own mind? Deciding how much do you give the person and how much to the robot?
So how do you split out that 50-50 partnership? Well, I think it's been an evolution as we meet every week and have discussed this. I know what, I have a couple, one of my first ideas was a CNI horse. So I came from Maine and that was a solution for there. And I tried to train the animal so I was aware of what an animal will do. I actually worked with a blindness organization to create a dog whispering program for the blind, because there's a variety of issues there. So I understand how that works. I think maybe I pulled that partnership from the dog and sort of implemented it into the robot. But I think what sensors this has and what it can do to see in the environment, there's phase 1, 2, and 3, and I think phase 1 would be fairly simple and straightforward. So initially, the user has a probably big role. Orientation, knowing where they want to go.
Yeah, I was just curious on your thought process.
Well, I think it's evolved, the process, and again, I'm not really an engineer or robotic person. I'm a person that's trying to make something happen. And so that's where I'm coming from, and I try to study how we navigate through the world as best I can.
Brian, what sort of feedback does the robot give the operator other than just twisting the handle and maybe the vibrations and sound? How do you communicate with the robot?
Well, I think in phase 1, if it just avoids, I think the user has to know where they want to go. And so if it avoids obstacles and keeps the blind person from tripping and pulls them in the direction they want to go, that, to me is phase 1. Again, it's a sensor-rich platform, and as things evolve, we can add all kinds of different sensors to this. Phase 2, I think Ed's thinking about, well, actually the mini guide on the handle, dogs, canes, and everything has a problem with anything around your face. Even that's a lower percentage of things that will hit you in the face. Tree branches. I found a lot of tree branches with my face, so I'm well versed in that. Even biking, that's real fun, you know, hit a tree branch at 20 miles an hour. But, so with the ultrasonic sensor, I think we can cover that range on the handle. So we're exploring all the sensors and trying to use this platform to guide our path and decide what we need to do and what's appropriate.
So do you see that in phase one, that the feedback you're getting from the robot is really obstacle avoidance and steering you in a path that avoids obstacles, or is it aware of a destination and is helping pull you in that direction? Or is there other feedback that you're getting? Is it really
I think in phase one it won't be aware of your, you know, if you're on a trip point A to point B, it won't be aware of the destination. This is a development project in conjunction with Carnegie Mellon and the group. And as Ed tells us, Ed Katz from Carnegie Mellon, I keep referring to Professor Ed, he says it's a development project. We're trying to get to a point of proof of concept, and so we're just exploring all the possibilities. But I think phase one, if we can just go in the direction the user wants to go and avoid obstacles, and that's pretty much all a cane or a dog does. But I am hoping more sophisticated things may evolve from this process. I don't know of anyone who's tried to put human navigation into a robot or take a look at this. The other outcome from this, if we get to phase 2 or 3, I think one of the things I've heard in the robotics club is that I keep hearing people say, "Oh, this robot's blind," and I say, "Well, I know how he feels," but I think an autonomous robot at some point will have robots running around autonomously. And I think they're going to have to solve a lot of the same things that we're looking at right now. So I think this could be, if this develops and evolves, what I'm working on, it could be a possible solution for an autonomous robot. Can you imagine Spring going out there all by himself in the public?
Yeah.
Yes, that's right.
Let me ask you this. Using a dog, say you want to go down to a store that's a couple blocks away. How do you tell the dog that's where you want to go? You know how to start off, hit the sidewalk, maybe turn the right direction, because you memorized quite a bit already. How much does a dog contribute, or does the dog just keep you from walking in the street? Or
primarily, the dog keeps you from, and it avoids obstacles, and most people have training, get blind rehab training, and again, they've gone, they have a professional take them to the store, the local store, or somewhere else, and so that's how the blind navigate and travel. Of course, with the GPS, there's where am I buttons that someone can now get real-time data of where they are, give or take 60 feet. And so the guide dog just primarily keeps them on a sidewalk, is aware of dangers, and the blind person has a mental map of where they want to go. And for the most part, when you become blind and you do your training, you have a professional take you to your local areas, and you have that mental map in your. But you end up, asking a variety of people on the street if you tend to get lost, or if the dog took a wrong turn, or saw a cat that he liked.
Brian, I was going to add that we have a few blind engineers here, and we have the indoor maps now in Google Maps for a lot of the places. We have airports, Home Depot, Best Buy, IKEA, and we have the Google campus. And so I've seen them walk around with the dog and then the phone. And the phone is sort of telling them to go somewhere new that they haven't been before, and the dog does just like you said, keeps them on the sidewalk and keeps them from running into planters and things like that. But the nice thing with cell phones now going indoors is you don't have the 60-foot problem. You start getting down to it, knowing what room you're in and which building you're exactly facing. Hopefully that'll go to more more internal places.
Yeah, that's someone else we should give a hand, is Google. I mean, they,
How are those internal maps created? How are those internal maps created? Just from drawings?
I can share that, no, but I don't think there's a way for you to create your own yet, to like submit like your house or your office yet. So I think they've started with high-profile collections, airports, and big box retailers.
Ah, right.
but for the blindness community, they've added the pedestrian mode to Google Maps. And I haven't really tested it and how it compares to the Trekker, or the Trekker Breeze, which is now this device that's similar to a little TV remote, which replaces a sophisticated tactile interface.
Yeah, Ed at Carnegie Mellon was working with his students for in-building navigation based on Wi-Fi and Bluetooth and phones, so they're getting to, I think, knowing what room they were in.
Yeah. Well, this is why I'm hopeful for this project, because there are so many things evolving. Didn't I hear that Google has some engineers that are working on just robot apps, that you just take your smartphone and download a robot app. I got the beer fetching app the other day. But, so all this technology is evolving, and I hope to grow and marry this project with the evolving technology.
One more question.
So don't dogs have a sense of danger and instinct for self-preservation? And doesn't that give them an advantage over the robots? Because the dog will lead you across the street if there are cars coming?
I don't really. The dogs have some training, and like all people, they have different personalities. And some dogs are much better than others. They will stop at a street crossing, but they're trained to know a street crossing, and they're not going to want to get hit by a car. But I think if you have a robot that has like LES sniffing data 360 degrees, it will pick up just like the autonomous car. It can search all the moving objects around it. So I think at some point, if we develop software that will analyze the LDS data and sniff the appropriate data, it won't fear cars. The robot won't fear anything, probably, humans included. There's going to be differences. The cane and the dog are different. But I really feel that, again, a sensor-rich platform that we can, evolve and add to is the way to go.
That's good. Is on the ground over there, just so.
Yeah, I threw it away. I don't want it.
You don't want it, okay. I just don't want you to trip over it. Okay, that concludes the presentation. Until about 10 o'clock, we just wander around and talk, and then we get kicked out, and some of us will keep on talking. Okay. So thank you very much for coming, and hopefully we'll see a lot of you at next month's meeting.